Well, we are here talking on geomatics and on geospatial information, but the important point is to convert information into knowledge and to question what information is coming from. So actually we have on one side data acquisition, and on the other side we have to integrate data, and the last comments from Mr. Ghani were very good. At the other side we have consumers of data. These are decision makers, governments, etc., who actually do not understand how data is acquired, how data are measured, how we get these data, and how we integrate this data. And more and more data is not just temperature or just nutrient or something. Data is always reference, geo-reference. Without coordinates, data won't make sense. And of course it is your business in geomatics to put this into maps, to assimilate this data, but the origin of the data is very heterogeneous. So the problem is to know details of data acquisition, and the people and the engineers who are producing sensors sometimes are not familiar what for the sensors are used, and the people who are taking the data are not really conscious about where the data comes from and where are the limitations, the mismatch, and the errors. The household of errors is a very, very important issue for the people who integrate data. Okay, I make a little switch. We are talking all today on this conference on Earth observation. Earth is, well, we think on forests, we think on agriculture. The big issue is how to feed 7 billion or in the near future 10 billion people. This is the political issue in good healthy conditions. And the Earth actually is not just Earth, terrestrial areas, but 2/3 or 72% of the Earth is ocean. And everything which is controlling climate and the energy household of the Earth is basically run by the ocean, because the heat capacity is equal to the energy capacity of the oceans. Of water is 1,000 times higher than that of the atmosphere. We feel the weather as this, but the household is in the ocean. Now coming back on data acquisition, the oceans are very poorly equipped with instruments, because it's difficult. You cannot deploy, you need vessels, you need a lot of money and infrastructure. And another physical limitation is that you cannot look into the water from a satellite because of the electrical conductivity. Light or electromagnetic waves like radar, etc., will not go into the ocean. So the problem is, if you really go to Earth observation, trying to understand climate change or whatever, you need to keep track of so many questions, issues, then looking for suitable sensors, for economic sensors, because just to have a good set of data, you need a tremendous amount of data. If you take always the most expensive sensors, then you cannot afford it, and so on. So what happened around the world? Around 100 years ago, people started measuring temperature and air pressure, and the data were basically in Europe and in North America, and it's very recent that you have good data set around the world, but not on the oceans, only on the terrestrial areas. Well, the atmosphere is accessible to satellite observation. I will not go into details. You guys have done it, and I will not repeat. But you need to understand the ocean circulation, etc. Another issue, of course, is that about 50 to 60% of men is living near the ocean, within 50 or 60 kilometers from the ocean. Mexico is a little bit special. Mexico DF is in the interior, 2,000 meters up in the mountains, but around the world, the coastal zones are the most sensitive ones, and the coastal zones are also the most important ones for feeding, because looking to food supply, fishery is like hunting, but you need to go to marine and to aquaculture. And when you have all these things, the coastal zones will be the most crucial ones for the future. And the problem is that you have conflicts of usage on coastal zones, conflicts of usage. You cannot have agriculture, aquaculture, where you have to install urbanization, city development, port development, industry, and so on. So you need to mitigate on conflicts of usage. And conflicts of usage, this is not just geospatial information, but it is, sorry? Yeah, I know. You need to spatial planning. And then you have more difficulties because you have heterogeneous data sets usually coming from the terrestrial side and from the water side. And the difficulties to get rid of are simple but stupid but difficult. So just to give one example, the geodetic reference systems on the water, on the sea side, are different than on land side. So you cannot integrate the data into the same maps. So again, you are on a geospatial issue to work on. Okay, now I will start with my slides. So what was going on? There's a lot of universities around the world and nice working groups, and they are working near the coast. They deploy instruments, let's say in the water. These are buoys, these are moorings, these are observations from the shoreline or from space. And so there's a working group in France and Germany and many in the United States and Mexico and so on around the world. And they're all doing something. Now the problem is how to integrate this. So what I want to present here is the JERICO program. As you mentioned, this is I think it's this way. Yeah. You can see it's the Joint European Research Infrastructure Network for Coastal Observations. The issue is to integrate the output of all these different working groups into, well, that's the dream, into one system where you can use and you have use the data, you can explain the data in the same manner, and we can exchange each other with best practice. What was the best instruments, how to integrate different instruments, and so on. And there's one more topic I have not addressed yet, is of course, you need, like for the meteorology, for weather, there's a demand on forecasts on sea state, forecasts on storms, on storm surges, good for fishery, good for mariculture, good for shipping, in case of search and rescue issues. So this is there are many applications, but the program I am, in a quick run now through the slides, want to explain you after this introduction, giving a little bit the frame, is to integrate these different approaches. So actually it is what is going on. It's a bottom-up approach and not a top-down approach. And the next one is, and you already mentioned it, we have a big difficulty in understanding these days. Policymakers think in terms of 5 years or depending on election cycles, and they think in projects. And what we need is really infrastructure on data acquisition, on data evaluation, on data interpretation, and providing, converting data into information, into knowledge for decision makers. And this is infrastructure. And now why we are here, because Mexico has similar difficulties and tasks ahead of, and working together, we can learn, exchange best practices, avoid mistakes, and not everything was brilliant, and we have a lot of problems. So working together, we can, well, that's a dream, end up maybe as a better world. Okay, now I give you a rough run through JERICO, and you can see here it's a whole bunch of equipments. We have a lot of equipment which is deployed from vessels. We have moorings like here with instruments which will collect data, any kind of data, and I will not go into details, and they will be picked up again by a vessel or sent by some data link, usually not by radio link because it does not work in the water. And then you can have data transmission via satellite and radar links to the shore side and so on. Monitoring river discharge, sewage outlets, which will hamper fishery, etc. And all these kind of topics I have already mentioned. Oops. So the idea is to have a pan-European program on coastal areas and to come from short-term projects to sustainable local or regional monitoring of the oceans. And details and technology, of course, will not be the same in the Mediterranean area with hot waters or in the Arctic oceans. Of course, these are details, but to have one framework on this, and that is JERICO, I want to introduce to Mexico, and we are already working together with the consortium of the Gulf to take advantage of this cooperation. And of course, also this is good for policymakers because if this cooperation is well performing, it helps us on the European side to get sustainable funding for infrastructure and not get rid of this project problem. Okay, so the idea is all what has been said in the introduction this morning by Rector Pina and others. Coastal observatories is what we need. We need harmonization of data and structures. We need to develop a vision on strategic where we want to go. And of course, already addressed by the other speakers, access to data, which is very, very important. So I will not repeat all this. I go through that furthermore. And of course, what is important also, we try to get is kind of branding, to have a label on good quality, to have quality-proof data, calibrated data, to label data with, to flag them whether they are better or poorer. And poor data is not necessarily bad data. It can be very useful because you have cheap instruments to get a whole, to cover gaps of data with less money and so on, which could help. And last but not least, we will go to well, this is not on this slide, to modeling of the data, to put the data into models and simulation computer programs which will forecast, and this is like space observation, but here you have models, they predict something, and then a couple of days or weeks, it depends on the scale, you see what is going on, whether there's an error or whether the model was performing well, and then you can adjust it. So you can save money on hardware, on deploying data, because you can bridge gaps of data acquisition because the model can do it. Okay, so what is one of the big successes? That actually we managed to have all European coastal countries, including Norway, which isn't even a member of the European Union, linked together and to have this JERICO program run. Problem of JERICO, it's a project and it will end next year. And right now we are about to try to get the JERICO do run, to have it for the next time. And cooperation with Mexico and other countries will help to implement JERICO 2. So again, a way of cooperation, you know, that's of beautiful mutual benefit to both of us. How many minutes?
50.
Okay. So now just I go through in a rush so that you get a slight glance of the complexity and the heterogeneity of JERICO actually. So we are using so-called ships of opportunity, putting instruments on ships, on ferry boats, which will just, when the ferry is going through and through, will pick up data. We have fixed platform, moorings and buoys, and gliders. These are robots actually, which will go up and down in the water column and measure temperature or salinity or nutrients or dissolved oxygens. There's a whole zoo of parameters, and to send them when they come up to the sea surface, then a radio link is possible to satellites, and they can provide the data to the Earth station. I present you these ideas because of the complexity, and that's not a one-man job. You need many, many working groups to develop sensors, to develop energy supply for these instruments, because you deploy them, and if the batteries are down after a day or a week, then it's another issue as if you have systems which could stand for half a year or even then. But then again, you have to pick them up. Or can we pay for expendable instruments, etc.? Okay, so JERICO is integrating all these, this was a little bit fast. And what is important for ocean and coastal observation, that's what OCO stands for, is to have an outcome on environmental status of the coastline. This can be algae blossom, biodiversity, can be acidification, eutrophication of the oceans, and so on. It helps us to understand the functioning of the coastal system, which is very sensitive and different from one region to another. So you need biologists, you need to integrate engineers, you need to integrate many people who just know to make geospatial information, data assimilation, modeling, or just software engineering. And a very important point also is validation of models. We already addressed ground truthing, so this is ground truthing in time. It's a very tedious job, and is also even in psychological way, it is very important but difficult, because you can bless someone who is doing a good job but has a problem with the real data, and to work in team you can adjust and take benefit out of that. Okay, so the important point of JERICO is, as you mentioned here, needs a common consensual strategy. And this is the success story of JERICO, that we managed to do this across all the countries and languages and different cultures and scientific expertise, which is varying from one side to another. Okay, maybe I just want to make a break here. I've said already a lot of things. There are, well, of course, questions of inventory, question of gaps in data, of instruments, how to fill them on regional levels. Of course, there's much more data in the North Sea area because it's surrounded by high industrialized countries, but also due to the oil business which is running in the North Sea area. So there's a lot of data. But there are other areas which are in the Gulf of Biscay which are pretty poor. The Arctic oceans are sensitive, or the Mediterranean. Just some images on where we deploy instruments on vessels of opportunity, and these are these kinds of robots being used to which will just gather data. The most important point is really data, data, data. There's a tremendous lack of data. And if you read in newspapers the 100 years storm surge or something of this is because there were just no data and no records before. So it goes through the newspapers. Okay, I want to make a stop here and switch to another presentation. If you can show me the folder, please. Hello? I want to show, no, sorry, it was good. Go back, please. No, go back to the folder. Yes, there's something which is called Cosina here. Yeah. Yes. Here I want to just to give you an insight, as JERICO is the frame on all the pan-European integration of coastal observation. And actually the drivers of the system is France, with a lot of marine research in Brest, and you will hear some contribution from that side, and in Germany, which is near Hamburg. And these two pieces can give you an insight on what we are doing in the daily work under the roof of JERICO, and actually similar systems are running in all the partner countries. So here we go. Cosina aims to provide knowledge and tools, and that can help, this is important, the benefit authorities and other stakeholders to manage their routine work, to manage emergency situations like accidents, oil spills, etc., and to evaluate trends when you're talking on climate change or whatever, sea level rise, is it really an issue and how does it go on, etc. This shows again the complexity of instruments all over. Sea floor instruments, even in deep water, have pressure problems, corrosion problems in the ocean, etc. And vessels is very expensive. It pays about 80 to 80,000 euros per day, things like this. So you need real good programs how to use these kinds of instruments. It is much more expensive than space observation. A satellite, once deployed, can provide much more, but you have no access into the water column with satellites. That's the point. I repeat myself. Okay, and this sketch is just describing, we need a synoptic description of the ocean. We need to understand key variables. We have a multidisciplinary approach, physical, chemical, biological parameters important. So that means we have multidisciplinary teams working together on the same topic, and again, combining observation and numerical modeling. Now what you can do if you look on the internet, all the data is open and available. You can look on the internet and the models are running. If I would have internet access here, I can show you in real time on maps what is the actual situation on currents or temperature or wave height in the North Sea or some other areas. So this integration is done here. This is just a sketch from the French side, Prévimère, which is the same system, but a little bit different. And you see the current situation with high tidal currents in the British Channel, which are switching from one side to the other. And the very sad story, the system ended by 2013, so last December, because it was just a project. So the funding and policy makers, they say, well, that's nice. We have the proof of concept. It works. And now what's happening? Do they want to switch it off? So that's the problem. Okay, I will thank you for this here. And I have a third presentation. That is the first one you had on your slide, please. It's the one PowerPoint. And then I will hopefully end within time.
Okay. Thank you, Doctor.
So, excuse me for this misunderstanding. I have not ended yet, but I still...
Sorry.
I thank you. So it's just to give you another insight. It's like zooming from the big JERICO to Cosina, which is one project in one country. As an example, it could be in another country as well. And now to just a piece of technology is how to monitor currents, wave heights, wind direction in situ from the shore with HF radar. It's not a microwave radar spinning on the vessel's top, which is supported with, with satellite data and buoy measurements, again the integration. That's a radar system which can look around beyond the horizon, so can cover 200 kilometers, so the entire EEZ, and in small cell sizes take the, with a high spatial and time resolution, spatial resolution, let's say 3 by 3 kilometers, and time resolution like 20 minutes or 15 minutes. And this makes, if you sum up the range and the cell size, you have 10,000 pieces of data with data concerning, let's say, wave height or current, and this in front of your ocean. So that means you have 50 maps per day of the current situation with the technology which is deployed on the shore. These are the antenna area. You can touch it, there's no danger. So this is technology to be deployed, and I know that Mexico already has, I think, 3 or 5 systems of that to have a view on the ocean. And again, one last comment, maybe I stop here, otherwise I will go into physics and explain how the coupling comes with the ocean and how you can get back the signals. So is it in situ measurement, because it's the physical phenomena on the cell outside here, or is it remote sensing, because the technology to measure this, to gather this, acquire this information is onshore? I don't know. It's a question of semantics. Well, Mexico is deploying these instruments. Just giving an example, now the problem is often for policymakers, what somebody has to pay for, and who takes the benefit? The benefit of having weather forecasts, nobody doubts. The state is since 100 years paying for meteorological services, because the farmers, they use it, the oil industry, if they have a difficult transportation to be done, a rig transport on offshore. The fishermen, they use weather forecasts, and tourists, of course, sailors, they like to have also nice weather forecasts. So it's for free. But the instrumentation and the services behind, they are paid by state. Now, concerning Earth observation and coastal observation near the ocean, of course, there are many, many people having benefits. These are city planners, safety of shipping, fishermen, and I already mentioned all these guys. And the service still does not exist. And I think if we are planning for future, the important thing is that we build up infrastructure for ocean monitoring and to deploy instruments, to install working groups, to develop human skills and expertise on all this, and to implement transfer of technology, let's say, from working groups like Gunnar, like forest observation, you can use a lot of know-how for coastal observation as well. And I think this will be the issue of this century, which is called the blue century, the century of the oceans. So now I thank you very much for your attention, and the time.
Thank you.
Okay. Bye-bye.